Um, Hello, everybody. In this part of the lecture, we will talk about uh, functional dependencies to achieve normalization. Okay. Okay. So, as we talked before, also to achieve normalization, you have to go or you have to take your data file or your whatever data you have through minimum through three level. So 1NF, 2NF, and then your 3NF. So as I said, at 3NF you have reached the Boyce Code's, I think, 13 principles of relational database management system. So you are so once you achieve that, you can now convert that file into a physical database. So let's see how we do it. So before we do that, let me talk about functional dependency, what that is, as you know, we will be using that as part of 2NF. So what a functional dependency is, that you have to mark that one attribute determining the value of another attribute. So what that means is, if you look at this data file employee, so if we look at a table, not table because we still have not reached a ER diagram or a DFD with employee. So it will have employee ID, name, first name, last name, department, salary, and address. So all these details for each row of data is dependent on or is determined by employee ID. So employee ID is the determinant of name of all these attributes, right? Same thing if I talk to student, like each student in my class, if I ask their name, address, date of birth, so I'm entering multiple lines of record. So let's say 25, as I have 24 students in this class. So each row of the student data, how I differentiate, or all these records are determined by student ID, because each row of data is different depending on student ID. So student ID is a determinant of all these other attributes. So these other attributes can only or when they are entered in a data file, they are recognized, they can be recognized differently for different students by this determinant, which is student ID. So as you must have guessed, the primary key, which could be employee ID, student ID, patient ID, customer ID, those all are determinant for attributes associated with it. But there's another twist to it, which we will see when we do 2NF in an example which we are about to do. So as I said earlier, you have to go through 1NF, 2NF, and 3NF, and there are requirements to fulfill to reach each of those 1NF. So the first NF is no multi-valued attribute like names. No, every attribute value is atomic. So that means you cannot have something like skills. So you got to separate it in some other way, because if I ask somebody skill, it will have more than one answer. And if you just fulfill this, you are in first normal form. So which is a pretty straightforward, simple. So let's say you went to some client and they said, this is what we have right now. This is our report. So, don't think of this as an Excel. You can think of it as an Excel file too. So this is something they gave you. They said, this is what we have right now. This could be an Excel file, or this could be an output, a report. And they say, we want to now switch over to a database to store all this information. So remember, reverse engineering, that's what we're going to do right now. So you said, okay, this is what your report is, or this is how your Excel file looks like. Let's convert this into a database. Let's do normalization on this first. So you look at this. The first step you will do is we cannot have any blanks, so you will enter data into here. So I know, so this will be repeat data 1006 1024 customer ID 2 furniture. So you cannot have any blanks there. So that's the first thing you will do. So no blanks, nothing. Then you might be thinking, how come they have customer name as a single attribute? Why not we have first name, last name? And again, this is a simple book example. What my looking at this I feel is these are the names of the company, and that's what they show it. If I was writing this example, I would have broken customer address into address and state, but that's fine. At least like I'm telling you, we should do that. So just by doing this, now we have this data file in 1NF. We have fulfilled the condition of 1NF. I do understand that order ID is getting repeated, but don't worry, we will fix that in a minute. Okay. So now, and you, if you guess that this order ID is getting repeated and all those, because you're right, because now if you apply insertion, deletion, update anomalies, all of them exist in this data file. So even though we have reached it in first NF, the anomalies still exist. Oops, what did I do? Anomalies still exist here. So like for example, if you see insertion anomaly, every time we enter a new order. So let's say if furniture gallery places one more order, every time we keep on have to add or repeat this customer information for every order ID they have placed. So this is getting repeated again and again. Deletion anomaly. If let's say we delete this record, we will lose all the information we have about entertainment center, because entertainment center exists only here. So if this record gets deleted, we will lose information about entertainment center as entertainment center is twice, so my mistake, sorry. Let's one second. I think what I meant was this one, because if we delete this record, we will lose all the information about writer's desk. So that's a deletion anomaly. Update anomaly would be if let's say, is there any product? Yes. So number 4 is repeated twice. If tomorrow the price of entertainment center, which is $650, if it changes, so we have to go back and change the price in 2 places in our data file. So one change requires multiple changes. So those are the 3 anomalies. So let's fix them. Let's fix them by doing second NF. So second NF is, you of course have reached first NF, first normal form. In addition to that, every non-key, one second, let me change the color of this. Every non-key attribute is fully functional, dependent on entire primary key. So first you might ask, what is this non-key? What does that mean? So if you think of a like table here, we don't have a table here. So if you think of a student table, so student table will have student ID, student first name, last name, address, city, things like that. So, and the table has something called primary key, and then a table has something called foreign key. So foreign key is an attribute which is primary key in some other table. So a table might have foreign key and primary key. So let me just open an Excel file. So, this I'm getting a little ahead of myself. This is a database which has been created based on ER diagram. But just to show you an example, you have customer ID is your primary key, then last name, first name, and artist ID is your foreign key. And the reason it is foreign key is because artist ID is a primary key in another table. So when we say every non-key, so in this example, non-key would be last name, first name, address, city, state, because customer ID is your primary key, artist ID is your foreign key. So that's simply what it means by non-key. Any attribute which is not primary key or foreign key. So every non-key attribute must be fully dependent on your entire primary key. So how do we do that? So to do this second NF, we had this table. So with this data file, so what you're gonna do is you take this all these columns, field names, you take all of them, and you write down all of them in a single row, multiple columns. So you do that, and then you start saying what attribute are fully dependent on or determined by some other key. So if you look at order ID is determinant of course, order date. Customer ID, I'm going to skip this for a minute, just for 1 minute. Product ID is determinant of product description, product finish, and product standard price. Okay. So again, if you remember our definition, every non-key attribute is fully functional dependent on entire primary key. So here comes the tricky part. So customer ID and customer name. Let's say if we have never bought anything from Amazon, let's say if I have never bought anything from Amazon, will my record exist in their customer database? It will not. Well, it might, because Amazon knows everybody. Just to go back to example, let's say a Cleveland Clinic database. If I have never been hospitalized, I've never gone to Cleveland Clinic as a patient, they will not have my record, my patient ID in their database. So coming back to this, a customer ID and customer name and address, of course, will only exist if first step is that the customer has placed an order, right? So you have taken that first step, you placed an order, and once you do that, then you become part of their database. So when you look at customer ID, customer name, or customer address, when you look at customer name and customer address, they are not fully dependent on or determined by customer ID. They're also driven by order ID. So in second NF, we will say that order ID is determinant of order date, customer ID, customer name, customer address. This part was pretty straightforward. Now comes another tricky part. Order quantity. Okay. So the order quantity which we have placed, what is that determined by? Of course, order ID. If you look at order ID, it is determined by order quantity. It is determined by order ID. But what is customer placing an order of? What is that? What is that order of? It's order of product as well. So looks like here, order quantity or order place, the quantity of order place is determined by both order ID and product ID, because it's order has been placed, so that's why we need an order ID, but the order has been placed for a product, so we need a product ID as well. Another example, good example of thinking that would be, if that part is confusing, think of your grade. So if you think of your grade, in this course, MBA 535, what is your, in a database, if I have to enter that grade information somewhere, what is that associated with? So you will say, of course, it is associated with my student ID. Makes sense. So does that mean that grade is, if it's driven by student ID, it will go in student table? No. First of all, grade is partially driven by student ID, because as a student you get multiple grades for multiple courses. So that means grade is also driven by course ID. So I hope with this you can better relate it. So both course ID and student ID drives a grade, because the reason for that is a course like MBA 535, I'll be giving out 24 grades this semester, right? So the grade cannot be driven just by course ID, because how will I differentiate those 24 grades? Same way, you as a student, let's say you're taking 2 courses, so that means your student ID this semester will get 2 grades. So how will I differentiate between those 2 grades with just student ID? So that's why something like grade, which I think you can relate better, is driven by both student ID and course ID. And same thing here, when you place an order, that order is driven by order ID, which of course is containing your customer ID at that point as well, and the product on which you are placing an order. So in 2NF, you clarify that which attribute is determinant of other attributes. So of course order ID and product ID. So order ID is determinant of all of them. Product ID is determinant of these. And for order quantity, both product ID and order ID is determining that. So we mark that. I know I made a really to mesh here. Okay, so once you do that, once we did that, you now break them. So that's what this is, break. So you brought your order right here, order date, customer ID, customer name, customer address, product ID on which you have product description, product finish, product price, and then order quantity is determined by both these. Okay, ignore this that it's saying is 3NF. So for now, this is in 2NF, this is in 2NF, and this is in 2NF. So we are done with 2NF, which was that every non-key attribute must be defined by an entire key, which is primary key, which we have done here. Now let's see what does 3NF says. 3NF says that you have reached 2NF plus no transitive dependency, or what does this now transitive dependency means? So let's understand that, and I think once you understand it, it's pretty straightforward. What transitive dependency is, or what that means is, what that means is that you have a primary key which determines another attribute which is also a primary key for a third determinant. So what does that mean? What does this confusing definition mean? So this is perfect right here. You have order ID. So let me draw that. So you have order ID, and next to it you have order date, and then you have customer ID, and then you have customer address and customer name, sorry. Okay, so in 3NF what it says is that you cannot have a primary key, which is this. So first, I'm sorry, let me take a step back. So what we are having is, we are having this primary key, which is determinant of customer ID And customer ID in turn is a dependent on both customer address and customer name. So this is your transitive dependency, that you have a determinant, or you have a key which is a determinant of another attribute, and that attribute in turn is a determinant of other attributes. So this sort of this double relationship which you cannot have in 3NF. So which is what we have right here. This primary key is determinant of customer ID, which in turn is itself determinant of these two. So to reach 3NF, what we need to do is we simply break this relationship into two further relations. And what results will we get? So we are breaking that. First will be pretty straightforward. Customer ID, customer name, and customer address. Now customer ID is determining both customer name and customer address. And if you still remember, what did I do? I ended up, okay, let me pause the video and draw this again. I don't want to waste your time. Okay, so I'd redraw it. So pretty straightforward. Customer ID is determinant of customer name and customer address, and then on the top we have order ID, which is determinant of order date. And there's one empty block. What is this for? This is for customer ID, because if you remember, customer ID is still driven by order date, because if there's not order ID, because if there's no order ID, if a certain customer has never placed an order, his ID will never be generated. And right here, this is where you see this. When you have this transitive dependency, non-key determinant becomes primary key in a new table. Customer ID, which was earlier a non-key, like it was neither a primary key or a foreign key at that time, so non-key, it became a primary key in its own new table. So this will be a customer table. That was the first part of solving transitive dependency. And the second part is, so the non-key determinant becomes primary key in the new table, and it also stays as foreign key in the old table. What was the old table? Order details was the old table. So that means customer ID remains in the old table as foreign key. And here it's primary key, and here this is primary key. So this is what normalization is, that we started first with something like this, or not even that, this, and we wanted to convert this into a table. So forget about data. First we are fixing these column names and trying to see what tables, how many tables, and what attributes we need in those tables. And our result was first this. So since this was a very simple example, when we did 2NF, and this is what we did in 2NF, with these two relation, order ID, product ID determining order quantity, and product ID determining product description, right away we were in 3NF. So even at the 2NF stage, because we were at 2NF, we right away reached the 3NF stage. But where did my marker go? But this relation was still in 3NF or 2NF. I'm sorry, 2NF. and on that relationship we apply the third NF, which is no more transitive dependency. So what that means is, in the end, and let me make this quickly. In the end, these are the 5 tables you will end up having this, and from here, one second, not 5 tables, sorry, 4 tables. So this is what you will end up having, which is you will end up having table, I want to call this this table, 1 table, 2 table, 3 tables, and 4 tables. Those are the 4 tables you will end up getting. This was still in 2NF. So now these 4 relationships all are in 3NF, and we will end up creating 4 tables. One table will be called product table, this one will be called customer table, this one will be called order table, and this would be called order line table. So where we started from, this will end up resulting in us creating these 4 tables, the top 4, and that would be the result of normalization. Okay, so I think I've been talking about foreign key quite a lot. Let me explain what foreign key as well. So what foreign key is, so if you look at this database, you have customer table, artist table, gallery table. So in this table, or you can think of this relation or entity, gallery ID is the primary key, here artist ID is the primary key, here customer ID is the primary key. So when primary key of one table is present in another table, in that table it is called foreign key. Again, when the primary key of one table is also present in another table, in that table it is called foreign key. So for customer table, in customer table, customer ID is the primary key, artist ID is foreign key. In artist table, artist ID is the primary key and gallery ID is the foreign key. And in gallery table, gallery ID is the primary key and it does not have any foreign key. And this relationship of primary key and foreign key is what connects these 2 tables together, and this relation is called creating a relation or a relational database. So this relation is what enables tables to be connected to each other so that you can pull out data from multiple tables. But how do we do that? Pulling out data from multiple tables, SQL and all those things, that's what we cover in MBA 545 or MIS 470. Okay. So that covers the normalization part of this chapter. The next part of this chapter, or the last part of this chapter, is that if you already have a well-structured, well-defined ER diagrams, how do we convert them into a relational model, which is very straightforward, because if you have created a fully structured, nice, fully structured ER diagram, you would have taken care of most of the things which we do a relational model, and you can very easily move from ER diagrams to relational model. So for example, this is an entity which you did in chapter number 7, and this entity will get converted into this relationship where you are making this single row multiple columns relation with customer ID, name, address, city, state, zip, discount. Again, I don't know why in this book they do that. These should be 3 different columns. If you have 2 entities with one-to-many relationship, like customer and order, one-to-many relationship, they again get converted into two separate relation, one for customer and one for order. And as you can see, one to many, so that means that the customer ID will go in order, and in that table it will be called foreign key, and customer ID is a primary key and order number is a primary key, and customer ID becomes foreign key because they are connected to each other, one to many. If you have many to many relationship with each other, like how you did in your chapter number 7, we take care of that in relational model. So the first thing you will do is you will create a relation for a product, which is right there. You got all those attributes there, and product ID is your primary key, and you create one relation for order like that, and order number is your primary key. And now they have many to many relationship among each other, and that means when you have many to many relationship, you introduce a third entity called associative entity, which will have both order number and product number, and what is this relationship for? Order quantity. So this is what exactly which we did in normalization as well. You had order ID, which was dependent on both order number and product ID. Or when I gave you an example of a student getting a grade, which will be dependent on both order number and product ID. One more way I'm going to confuse you right now. So you're in this relation, order number is both foreign key and primary key in conjunction with product ID, which is also both foreign key and primary key. The reason they are foreign key is because product ID is coming from here and order number is coming from here, and they are primary key because they combine together, make a unique record through which we can recognize order quantity. Going back all the way, I'm going to quickly go back to something, and let's see if I have it. I do not. So this is a perfect example of, again, your grade. So your grade is determined by course ID and student ID. So they both together make a unique combination, like MBA, let's say 535, and let's say student ID 0056. So they together make a unique combination or a primary key for each individual grade. So for such associative entities, you need two primary keys combined together as composite primary key. This is what we're doing. If this is sounding a little bit too heavy, too confusing, go back, revise your chapter number 7 again. And as I said earlier too, we do, or look at some of the advanced question I showed you in chapter number 7. And as I said before also, entity relationship diagrams and this database, this normalization as part of database design, this is a little bit outside the scope of this course, and we do it in much more detail in MBA 545, where we do learn just the database design. That's all we do. We don't do system analysis. We just right away jump into database designing. Okay. And then you can see how a unary relationship where a entity is entity has a relationship with itself. How do we represent that? Looks like I deleted it. I'll add that back here. Okay. Some of the other things about database design is when you are choosing a database design, you need to choose. Oh, let me take that out. you need to choose date type. You can think of it that in journal you can say there are three kinds of data types: text, number, date, or further would be currency, memo, or all those. But anything which is text is considered text. You use data type text. Anything which is number, you classify number. Date of birth would be date, time. Income would be currency, or numbers. Phone number would be a number. So you have data type. Main data types are text, number, and date, time. And then you can also specify their length, that how much length are you expecting in each of them, especially for anything which is text. Okay, so I think that's all I wanted to cover from this chapter.